context as to why. What is it really that's changing in the world that's allowing us to create these new product categories, tackle new problems? And that's that we're living in exponential times. I'm sure everybody in this room, given where we live, is familiar with Moore's Law. It's the reason that your new iPhone is going to be useless in 2 or 3 years. It's a driving force of technology of the industry. And we have to remember that even though we hear about it all the time, even though we're inundated by this discussion, we are still at the very beginning. We're at the knee curve. If we look at the acceleration of technology over time, we see that we're just getting started. So the most obvious exponential technology to penetrate the world and proliferate is, of course, the cell phone. You see it everywhere now. There are over 1 billion cell phones in Africa. There are more cell phones than toilets in India. Smartphones are ridiculously cheap now. Thanks to companies like Xiaomi in China, you can buy an $18 smartphone. A smartphone, not just a regular dumb phone, $18. This is where we're at right now with these components. China, 600 million smartphones. Now, what is a smartphone? It's a collection of sensors. You open up your phone, you'll find a whole array of devices and sensors and computers in there that would have cost hundreds of thousands of dollars a few decades ago. It would have weighed tens of dozens of pounds a few decades ago. Now it just sits in your pocket waiting for you to check email or tweet. But what's most interesting is not the smartphone itself, it's what it's enabled. Essentially, in the race to create smartphones, with each company competing against one another, we have what's called the peace dividends of smartphones. That's what Chris Anderson from Andreessen Horowitz calls it. Essentially, what that refers to is all the benefits we've derived in that process that have nothing to do with smartphones. Those components, those sensors, those parts are now moving a whole host of technologies forward. Virtual reality, Internet of Things, self-driving cars, nanosatellites. These are all thanks to the revolution in smartphones, to the economic competition and advantage that gave companies. And really, what is driving this new bionic world that we're entering into? What is it that's allowing us to turn the corner and make things like the $6 Million Man sort of real? It's advances in specific technologies, in sensors, in scanning, printing, processing, algorithms, interactions, and interfaces. And I'm going to walk you through each of these and explain what I mean. So first, let's clarify something here. It's not about advances in technologies. To understand where things are headed, don't look to one technology and try to guess where it will be in 5 or 10 years. Instead, look at the convergence of technologies. Look at which technologies are coming together. If you want to figure out where will the actual shipped products be, where will the actual innovation that reaches customers, look at the convergence, not the technology. So in our particular work, in our particular focus, we're going to be looking at network, sensors, AI, robotics, 3D printing, that sort of thing. And it's a convergence of them that comes together and creates entirely new products. And those are also completely hard to guess and to predict in the beginning. If you look at the revolution in deep learning today, that was thanks to NVIDIA and them making a graphics chip. That was for gamers. And it ended up revolutionizing healthcare, many, many other fields. So we see this play out all the time. This is far more so than the exponential curve. This is a story of technology. So if we look at 3D printing and the great advances that are being made there, we have to understand that 3D printing is not just a technical revolution, it is also a business revolution. It completely upends the supply chain and the way logistics work today. It used to be that you wanted a product, you would have it fabricated possibly in different parts of the world or in one factory in one corner of the world, and then you would ship it to your customer. 3D printing turns that upside down. Now you send a file. You send a file digitally, and if you have local materials and a printer, then you can fabricate that yourself in the area that you are. So keep that in mind when I describe some of these open source projects that are coming. One of them is called eNable. And what this is it's essentially a hobbyist project. It's a group of people online that originally they were going to a party and they wanted to make a prosthetic hand. So they did, and they put a video on YouTube. And then they heard from somebody in South Africa who had lost their hand in a mining accident. And he said, "This is really cool. Can I make this here?" And they said, "Yeah, here are our plans." And then a child in South Africa approached them, and it snowballed into a whole community. We have 10,000 people now that are literally printing hands for each other now. They're quite literally lending a helping hand to each other. And that is because essentially they've released a file. These people innovate on it, they iterate on it, they look at they could customize it for each person's need. You have parents customizing hands for children, children customizing hands for other children and designing it themselves. It's really an amazing thing to see. Now, I don't mean to say that these devices are what we would consider medical devices. These are not rigorous, these will not pass FDA approval. But what you're seeing is the beginnings of the network effects of 3D printing. The fact that now that 3D printers are out in the wild, out in the world, owned by individuals and owned by small companies, you can now send a file and activate an entire community around a problem. Now, I mentioned the $6 million man is coming. Now, he's not quite here yet. But what I mean to say is that this is not science fiction anymore. The components, the parts, we're starting to see the beginnings of these, of a bionic human being, of a bionic person. So first, this is Ethor's friend Jason. And Jason is paralyzed, and he wanted to walk his daughter down the aisle at her wedding. And Ethor and some of his friends made this possible, essentially, by providing an exoskeleton. So we are seeing, in some cases, the paralyzed walking again. This is no longer just an entirely fictional thing, just a fringe thing. In fact, Ethor showed the world that this was possible in 2011 on the TED stage. That woman there was one of the first people to walk in an exoskeleton. That's, I believe, the first time she ever walked, right?
Yeah, pretty much.
Pretty much.
After 19 years.
Right, in 19 years, absolutely. Now, this was in 2011, and when he did this, there was only 2 companies making exoskeletons. Today, there are over 20 companies making exoskeletons. And their approaches have changed. This equipment used to cost hundreds of thousands of dollars, millions of dollars. Now you can buy a version of an exoskeleton for $100K or $40K. And I don't mean to say these are cheap and affordable enough for everyone today, but we are headed in that direction. And there's some very interesting approaches being taken to driving down the cost. Some companies are choosing your standard manufacturing approaches where you reach economies of scale and therefore you bring down the cost. Others are looking at changing sensors and parts, using cheaper equipment to reduce the cost. Others are actually looking at simplifying the machines. It turns out for a lot of cases you don't need to wear a giant robot. You only need certain mechanical boosts, certain sensors, certain aspects of it.